this lecture we will find the radius of the smaller circle. In the drawing we have two circles and there is an internal lunge between the two circles at this point. Let's define the point, this point as point N. Point N is the point of contact between the small circle to the bigger circle, and we know that AC equals to 9 units and BD equals to 4 units. And let's define the center of the small circle at this point. Let's call this point point P, and let's define, so point P is the center of the small circle. Let's define the center of the bigger circle at this point. Let's call this point point Q. Again, point Q is the center of the big circle, and we will draw a radius of the smaller circle here. Actually, we have here 3 tangents to the circle. That is a tangent to the circle. This line segment is tangent to the circle at point, let's call this point A, and we also have another tangent to the circle at this point. Let's call this point B, and we have third tangent to the circle at this point. Let's call this point C, and then we will draw a radius to the touching point between the tangent to the circle. Actually, as you know, the angle between a radius and its tangent is equal to 90 degrees. So if this is the radius, then the angle between the radius to its tangent is 90 degrees. The radius is perpendicular to its tangent, and then we will draw a second radius to the tangent at this point. Again, the radius is perpendicular to its tangent. For that reason, this angle is a right angle, it equals to 90 degrees. And then we will draw a third radius to the point of contact between the tangent to the circle, that is to say to point B, and again the radius is perpendicular to its tangent, and for that reason this angle equals to 90 degrees. Okay, and let's define. So actually CB is the radius. Here we have a rectangle. APBC is a rectangle, and for that reason BC is also the radius of the small circle. BC equals to small r. BC equals to small r, and we will define the radius of the big circle as capital R. R is the radius of the big circle, again capital R is the radius of the big circle, and small r is the radius of the small circle. Small r is the radius of the small circle. Okay, small r is the radius of the small circle, and actually in the shape APCB we have actually all the angles inside the shape of this shape are right angles, and therefore shape APCB is a rectangle, and therefore BC equals to AP, and AP equals to the radius of the circle, of the small circle. Therefore BC also, that is equals to AP, BC also equals to the radius of the small circle. BC equals to R. Okay, BC equals to R, and let's define BQ as X. BQ equals to X. Okay, BQ equals to X, and the radius of the big circle R will be equal to 9 plus R minus X. 9 plus 9 plus CQ, yes, 9 plus CQ. The radius of the big circle equals to 9 plus CQ, and what is the value of CQ? CQ equals to R, or CQ equals to BC minus QB. Okay, CQ equals to BC minus QB, Okay, CQ equals to BC minus QB, and we know that BC equals to R, and we define QB as X. So actually CQ equals to R minus X. Okay, CQ equals to R minus X. Therefore, the radius of the big circle will be equal to 9 units plus R minus 6. Okay, so we have equation number 1 that states that the radius of the big circle will be equal to 9 plus R minus 6. Okay, but we can calculate the radius of the big circle from the other side, because actually Q is the center of the big circle, so QB is the radius of the big circle, and the value of QB, that is the radius of the circle, will be equal to 4 plus BD, but BD is actually the radius of the small circle. BD plus R plus X. Okay, so the radius of the big circle from the other side is 4 plus R plus X. Okay, the radius BQ equals to BD plus BD plus QB. Okay, so the radius of the circle, of the big circle, equals to 4 plus BD is actually R, the radius of the small circle, because actually shape PCBD is a rectangle. Therefore BD equals to PC, and BD equals to PC, and PC equals to the radius, so PC equals to BD, so actually BD also equals to the radius of the circle. So actually the radius of the big circle equals to 4 plus R plus X. Okay, so equation number 1 is the radius, the expression of the radius of the big radius of the circle, and equation number 2 is also the radius of the big circle. So we can compare equation number 1 to equation number 2, because both equations are actually the radius of the big circle. So we will create equation number 3 that states that equation number 1, that is the radius of the big circle, equals to equation number 2, that is also the radius of the big circle, and we will get that 9 plus R minus X equals to 4 plus R minus X So equation number 3 states that the radius of the circle, the radius of the big circle, when we calculated it from one side, equals to the radius of the big circle when we calculated it from the other side. So here we have r on both sides of the equation, so we can cancel r. And what is left after we cancelled r is nine minus x equals to 4 plus x. Okay, we got that 9 minus x equals to 4 plus x. Here we'll subtract 4 from equation number 3 and we will get that 5 minus x equals to x. We subtracted 4 from equation number 3. Here we will add x to equation number 3 and we will get that 5 equals to 2x. So here we will divide equation number 3 by 2 in order to get the value of x, and we will get that x equals to 2.5 units. Okay, we found out the value of x. X is actually QB. QB equals to 2.5 units. Okay. So actually we can put the value of x in equation number 1 and we will get that capital R equals to 9 plus R minus x. X is 2.5. So we have the equation that states that capital R equals to 9 minus 2.5 plus R is actually 6.5 plus R. So the radius of the big circle equals to 6.5 plus the radius of the small circle, or in other words, the radius of the big circle is bigger by 6.5 units from the radius of the small circle. Then we have actually a rule that states that when is an internal lunge between two circles, then the distance between the centers of the circles is actually equal to the difference between the radiuses of the two circles. Okay, I will write it down according to rule number 1. States that when there is internal lunge or when two circles have internal lunge, then the distance between the centers of the circles is equal to the difference between the radiuses of the circle. Okay, so I will read rule number 1 again. Rule number 1 states that when two circles have internal lunge or internal lunge between them, okay, when two circles have internal lunge between them, then the distance between the centers of the circles is equal to the difference between the radiuses of the circles. So we can implement rule number 1 in our drawing, because we have here two circles that have internal lunge between them. The internal lunge between them is at point N. Therefore, the distance between the centers of the two circles. Here P is the center of the small circle, and Q is the center of the big circle. So the distance between the centers of the two circles is PQ. Okay, PQ is the distance between the two circles. Okay, PQ is the distance between the centers of the two circles. Okay, P is the center of the small circle and QU is the center of the big circle. So PQ is the distance between the centers of the two circles, and according to rule number one, PQ, the distance between the centers of the two circles, equal to the difference between the radiuses of the two circles. PQ equals to capital R minus small r. Okay, so that will be our question number 4. PQ equals to R minus R. Okay, according to rule number 1, the distance between the centers of the two circles with an internal lunge is equal to PQ, and PQ equals to the differences between the two radiuses, and the differences between the two radiuses is actually R, capital R minus small r, because capital R is the radius of the big circle and small r is the radius of the small circle. So capital R minus small r equals to the differences between the radiuses of the two circles, and according to rule number 1, that is equals to the distance between the centers of the two circles. That is to say, PQ equals to R minus R. Okay, so for the question number 4, we will get that R equals to PQ plus R. So I actually added R to equation number 1, and we got that PQ equals to R equals capital R equals to PQ plus R. Okay, but actually we have already found out, according to equation number 3, that according to equation number 3, or actually according to equation number 1, according to equation number 1, yes, according to equation number 1, we have already found out that capital R equals to 6.5 plus R. Okay, capital R equals to 6.5 plus small r. Okay, capital R equals to 6.5 plus r. Okay, so equation number 4 is actually the radius of the big circle, and equation number 1 is also the radius of the big circle. So we can compare equation number 1 to equation number 4 because both of them are the radius of the big circle. That will be equation number 5. That states that 6.5 plus small r equals to PQ plus small r. We compare the equation number 4 to equation number 3, and we have equation number 5. So here we have small r in one side of the equation and we have small r in the other side of the equation, so we can cancel r, and we will get that PQ equals to 6.5 units. We found out the value of PQ. PQ equals to 6.5 units. And we have already found out that the value of X is 2.5 units. Okay, so actually here we have a right triangle . Actually, triangle PQB is a right triangle because this angle PBD is a right angle. Okay, so triangle PQB is a right triangle. Triangle PQB is a right triangle. Okay. Triangle PQB is a right triangle, therefore we can use the Pythagorean theorem in order to find out the value of r, because actually PB is the radius of the small circle. We know that X equals to 2.5 units and PQ equals to 6.5 units. So according to the Pythagorean theorem, PQ square, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to x squared plus r squared. Okay, according to the Pythagorean theorem, PQ squared equals to x squared plus r squared. We have already found out that PQ equals to 6.5 units and x equals to 2.5 units. Okay, and the only missing variable is r. Okay, that is according to the Pythagorean theorem. So PQ squared is 6.5 square equals to x squared, that is 2.5 square plus r square. Okay, we substituted PQ by 6.5 and x by 2.5. 6.5 square is 42.25 and 2.5 square is 6.25 plus r square. Okay, we got that 6.5 is 42.25 and 2.5 square equals to 6.25 units. So we will subtract 6.25 from this equality and we will get that r square equals to 36. Okay, we got that r square equals to 36. Here we will take a root out of this equality and we will find out that the radius of the small circle equals to 6 units. Okay, so we found out the answer to the question. The answer is that the radius of the small circle equals to 6.6 units. Okay, now I will summarize the lecture. Actually, we wanted to find out the radius of the small circle. We have two circles with an internal lunge with each other. The point of contact between the two circles is at point N, this point, and this angle is 90 degrees, this angle is 90 degrees, and we know that AC equals to 9 units and BD equals to 4 units, and we want to find out the radius of the small circle. So we defined capital R as the radius of the big circle and small r as the radius of the small circle, and then we actually have 3 tangents to the small circle. Okay, so this segment line is tangent to the circle at point A. Line segment CD is tangent to the circle at point B, and this line segment is tangent to the circle at point C. Okay. We know that so we actually drew 3 radiuses to the point of contact between the tangent to the circle. We draw the first radius to point A, and as you already know, the radius is perpendicular to its tangent. So the radius is perpendicular to its tangent. That is to say, the radius creates 90 degrees with its tangent. Therefore, here we have 90 degrees. And also, this radius is perpendicular to its tangent at point B. We have a tangent, line segment CD is tangent to the circle. So the radius is perpendicular to its tangent. So this angle is also 90 degrees. And also we do the third radius at the point of contact between the tangent to the circle, point C. So the radius is perpendicular to its tangent, therefore this angle is also a right angle. Okay, so actually we created here 2 rectangles. So PC is the radius of the small circle, and PC equals to BD, because PC and BD are 2 sides, 2 opposite sides that also parallel to each other in a rectangle. Therefore, they are equal to each other. And we have also the second rectangle. Shape APBC is a rectangle. And therefore, AP, that is the radius of the small circle, equals to BC. So BC is also the radius of the small circle. Okay, so we know that BD is the radius of the small circle, and also BC is the radius of the small circle. And we defined BQ as X. So CQ will be equal to CB, that is the radius of the circle, minus QB, that is X. So CQ equals to CB, that is the radius of the circle, minus QB, that is X. So CQ equals to R minus X. Okay? And we calculated the radius of the big circle from its 2 sides, from this side and from the other side. Okay, so the radius of the big circle from this side, Q is the center of the big circle and P is the center of the small circle. So AQ is the radius of the big circle. AQ equals to AC plus QC. That is to say, AQ equals to 9 plus R minus X. Okay? AQ, that is the radius of the big circle, equals to 9 plus R minus X. AC plus CQ, so 9 plus R minus X. That is the radius of the big circle from one side. And we calculated, so that is equation number 1. And we calculated the radius of the big circle from the other side. QB is also the radius of the big circle, so QB will be equal to 9 plus R plus X. QB equals to BD, to QB equals to 4 plus R plus X. Okay, the size of QB is X plus R plus 4. Okay, that is our second equation. So both equations 1 and 2, they are the radius of the big circle. So we can compare equation number 1 to equation number 2, and we created equation number 3. And by solving equation number 3, we got that the value of x is 2.5 units. We found out that the value of x, that is actually QB, equals to 2.5 units. Okay, and because of the fact that x equals to 2.5 units, we can put x in the first equation, and we will get that R equals to 9 plus small r minus x, that is 2.5. That is to say, R equals to 6.5 units plus small r. Okay, so we got that R, capital R, equals to 6.5 plus small r. Okay, then we have actually rule number 1 that states that when two circles have internal length between them, then the distance between the centers of the circles is equal to the difference between the radiuses of the circles. Okay, so here in the drawing we have two circles with an internal length. The point of contact between them is at point N. Therefore, we can implement rule number 1 in our drawing. According to rule number 1, the distance between the centers of the two circles is equal to the difference between the radiuses of the circles. The center of the small circle is at point P, and the center of the big circle is at point Q. So the distance between the centers of the two circles is actually PQ. According to rule number 1, PQ equals to the differences between the radiuses of the two circles. That is to say, it equals to capital R minus small r. Or in other words, PQ equals to capital R minus small r. Okay? Okay, we have, according to rule number 1, the implementation of rule number 1 in our drawing gives us equation number 4 that states that PQ equals to capital R minus small r, because of the fact that the distance between the centers of the two circles, that is to say PQ, equals to the differences between the radiuses, the difference between the radiuses of the two circles. That is to say PQ equals to capital R minus small r. This is equation number 4 that states that PQ equals to capital R minus small r. Okay, so we actually added R. We added R to the fourth equation, and we got that R equals to PQ plus R. But for equation number 1, we've already got the equality that R equals to 6.5 plus R. So we can compare equation number 4 to equation number 1 because both of them are radiuses of the big circle. Okay, so we get that by comparing equation number 4 to equation number 1, we will get that PQ equals to 6.5 units. Okay, because here we have in equation number 5, 6.5 plus small r equals to PQ plus small r. So small r is cancelled because we have small r in both sides of the equation, so small r is cancelled, and we got the value of PQ equals to 6.5 units. And we have already got the value of x. X equals to 2.5 units. So here we have actually a right triangle. PQB is a right triangle. We know that x equals to 2.5 units. PQ, that is the hypotenuse of this right triangle, is 6.5 units. And the only missing variable is the radius of the small circle. PB, that is the radius of the small circle. So we solved very simple equation. We have according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say PQ square equals to QB square plus PB square. Okay, or PQ equals to x square plus r square. We know that PQ equals to 6.5 units, x equals to 2.5 units, and we solved this simple equation, and we found out that the radius of the small circle equals to 6 units. Again, the radius of the small circle equals to 6 units. Okay, thank you very much.